Imagine a floating resort about as long as the Eiffel Tower is tall, complete with water slides, multiple swimming pools, and even an ice skating rink. Nearly 10,000 people can be on board at the same time, yet in the open ocean, it is not connected to any city's water, electricity, or fuel network. So where does this massive ship get all its power? And how does it keep an entire city running in the middle of the sea? It has 2,805 guest rooms, more than the number of rooms in many large five-star hotels. The ship has a gross tonnage of 250,800. This is not its actual weight, but a measurement based on the total enclosed space inside the vessel. Even so, this enormous ship still floats on water, and when it departs from Miami, nearly 10,000 people, including the crew, can be on board. The ship is called Icon of the Seas, currently the largest cruise ship in the world. It reportedly cost around $2 billion to build, and hidden inside it are secrets that Royal Caribbean has spent the past 2 years trying to keep out of newspaper headlines. But if a ship this massive has no conventional rudder or steering system, how does it change direction? And where does the fresh water for nearly 10,000 people in the middle of the ocean come from every day? Throughout this video, we will answer these questions one by one. But first, we need to understand just how enormous the real challenge is. Imagine being asked tomorrow to build a small city for nearly 10,000 people. It would need fresh water, uninterrupted electricity, waste management, a hospital, kitchens, and almost everything required to keep a city running. So far, that sounds normal. But now there is one condition. The city cannot be connected to any water pipes, power grid, or municipal waste system. No garbage trucks can come from the outside. And despite all of that, the entire city must still move across the ocean from one port to another. Every time Icon of the Seas raises its anchor and begins a voyage, it solves exactly this difficult problem. Let's begin with the most essential resource, water. The ship can carry up to 7,600 passengers and around 2,350 crew members, providing showers, cooking, laundry, swimming pools, spas, and cleaning services for that many people requires hundreds of thousands of gallons of fresh water every day. And if that system stopped working in the open ocean, normal operations across the entire floating city would begin to break down very quickly. Of course, there is water everywhere, the endless blue water of the Caribbean Sea. But with about 35 grams of salt in every liter, that water cannot be consumed directly. In fact, the excess salt can pull even more water from the body, making dehydration worse instead of relieving thirst. So where does all the fresh water for nearly 10,000 people come from? Icon of the Seas produces about 93% of the fresh water it needs directly from the ocean. A reverse osmosis system located on the ship's lower decks handles this process. The process is simple. Powerful pumps force seawater through extremely fine membranes under intense pressure. The openings in these membranes are so small that salt and most impurities are trapped, while water molecules pass through to the other side. The water's then further purified and adjusted with the necessary minerals before it is ready for use. This is how the ship continues producing its own water for showers, cooking, and drinking, hour after hour in the middle of the ocean. In the end, the salty sea surrounding the ship becomes the largest source of water for this floating city. But producing water creates another major challenge: electricity. Keeping the reverse osmosis plant running for hours requires an enormous amount of power, and in the open ocean, the ship has to generate that electricity itself. At the heart of Icon of the Seas are 6 dual-fuel engines built by Finland's Wärtsilä. 3 of them have 14 cylinders, while the other 3 have 12. Together, they can produce about 67.5 megawatts of power, roughly the output of a small power plant. But the most important point is that these engines do not directly turn the propellers. They first generate electricity, and that electricity powers almost everything on the ship. Its 22 elevators, the air conditioning systems in 2,805 rooms, massive kitchens, lighting, water plant, and finally the electric propulsion system that moves the ship forward, all depend on the same power network. In other words, this is not just a ship, it is a fully functioning city moving across the ocean with its own power plant. Now let's look at a fact about how this ship moves, one that very few people know. At the beginning of the video, We said that Icon of the Seas has no conventional rudder or steering fin. That is 100% true. It also does not use the long transmission shafts found on traditional ships, running from the engines to fixed propellers at the stern. Instead, 3 Azipod units built by ABB are installed beneath the ship. Each one produces 20 megawatts, about 27,000 horsepower. Together, the 3 units deliver nearly 60 megawatts of electric power to move the ship forward. You can think of an Azipod as a giant electric outboard motor for a boat. The difference is that it hangs beneath the hull, and the electric motor inside directly turns the massive propeller. There is no need for a separate gearbox or a long mechanical shaft between them, but its most remarkable ability is that the entire unit can rotate 360 degrees around its own axis. On a conventional ship, the rudder redirects the flow of water to change direction. Here, the propellers themselves rotate in any direction needed and push the water accordingly, allowing the ship to move forward, backward, or even sideways. This gives the captain extremely precise control over the ship's direction and position. When entering a port or docking, the Azipods work together with the bow thrusters at the front of the ship. That is why this 250,800 gross ton vessel can slowly move sideways, something that is difficult to believe until you see a structure this massive doing it with your own eyes. According to ABB, ships equipped with Azipods can maintain directional control even during an emergency stop and may come to a complete stop in up to 50% less time than ships using conventional shaft line systems. And because there is no long mechanical connection between the engines and the propellers, noise and vibration are also greatly reduced. Passengers barely feel the powerful propulsion system operating beneath them. In other words, this floating city carrying nearly 10,000 people is not only powerful, it also moves with incredible precision and smoothness. If this fact surprised you, subscribe to the channel, because in the next section, the challenge becomes even bigger. But the real challenge is not just how this ship moves. The bigger question is this: while at sea, how much food do nearly 10,000 people consume over 7 days? How many supplies are needed? And how much waste is produced in the end? Icon of the Seas has more than 40 places to eat and drink. Not all of them are open 24 hours a day, but food is being served somewhere on the ship at almost every hour of the day. Before each voyage, tons of food and essential supplies are loaded onto the ship. These include meat, seafood, fruits, dairy products, bread, beverages, and ingredients used in cuisines from different parts of the world. Its supply system is much like operating a large supermarket chain. Different types of food must be kept at the correct temperatures across multiple refrigerated storage areas. Thousands of products must be tracked, and planners must know in advance which days the ship will be at sea and which days it will stop at a port. That is because on port days, many passengers leave the ship for several hours, which changes the demand for food on board. Now you may be wondering, how much does it cost to spend a week on this enormous floating resort? Not yet. We will answer that question in the final part of the video. Using this enormous amount of food and essential supplies creates tons of waste every day, but there are no landfills in the middle of the ocean, and municipal garbage trucks cannot reach the ship. So what does Icon of the Seas do with all that waste? The ship uses one of the cruise industry's first onboard waste-to-energy technologies. It is called microwave-assisted pyrolysis. Leftover food and other organic waste enter a special chamber where microwave heat breaks them down without oxygen. This process produces synthetic gas, or syngas, which the ship can use as an energy source. It also creates a solid material called biochar, which can be used to improve soil nutrients. In other words, part of the food that was waste just moments earlier can be reused on board, while another part becomes useful in a new form. But the ship does not recover energy only from waste. When the Wärtsilä engines are running, an enormous amount of heat leaves through the exhaust. Normally, that heat would be lost to the air, but Icon of the Seas uses a heat recovery system to capture it and convert it into additional power, up to 3 megawatts. The principle is much like a power plant. The engines first produce energy from the fuel, and then even more energy is recovered from the heat that would otherwise be wasted. The difference is that the entire system operates inside the engine room of a cruise ship moving across the ocean. Now the question is, how does a ship this massive carry enough fuel to spend an entire week at sea? Icon of the Seas mainly uses liquefied natural gas, or LNG. When natural gas is cooled to about -260 degrees Fahrenheit or -162 degrees Celsius, it turns into a liquid. At that point, its volume becomes about 600 times smaller than in its gaseous form, allowing a huge amount of fuel to be stored in a relatively small space. The LNG is stored in two massive cryogenic tanks built into the ship's structure. Each tank is about 90 feet long, and an empty tank alone weighs approximately 307 tons. So the 307-ton figure is not the tank's fuel capacity. Before each voyage, the tanks are filled through special pipes at the port. The fuel then flows to the 6 Wärtsilä engines, which generate the electricity the ship needs. Now we come to a question that Royal Caribbean may not be eager to answer. The company presents LNG as one of the cleaner marine fuels currently available. That claim is not entirely wrong. When burned in a ship's engine, LNG can produce about 25% less direct carbon dioxide than conventional marine fuel. Royal Caribbean also claims that, in terms of carbon emissions, Icon of the Seas is about 24% more efficient than the standard set by the International Maritime Organization for new ships. Those numbers sound impressive, but they leave out one major part of the story. What the fuel emits when it is burned on board is not the only thing that matters. During Icon's first voyage, Brian Comer, director of the Marine Program at the International Council on Clean Transportation, told Reuters that when the entire life cycle is considered, from production and transportation to use on board, marine LNG could produce more than 120% more greenhouse gas emissions than marine gas oil. How can a fuel that releases less CO2 when burned become more harmful when the full calculation is considered? The answer is methane. LNG is essentially methane that has been cooled until it becomes a liquid. When methane burns completely inside an engine, it mainly turns into carbon dioxide and water. But in reality, not every molecule burns completely. Some methane escapes directly into the atmosphere through the exhaust. This is known as methane slip. The problem is that even a small amount of methane can have a major impact over a short period. During its first 20 years in the atmosphere, methane can trap about 80 times more heat than the same amount of carbon dioxide. And the low-pressure dual-fuel engines used on cruise ships like Icon carry a relatively higher risk of methane slip. This is where the two sides disagree. The company points to lower direct CO2 emissions, improved engines, heat recovery, more efficient routes, and reduced fuel use. Critics argue that if you only measure the CO2 coming from the ship's exhaust, much of the emissions from fuel production, transportation, and unburned methane remain outside the calculation. Royal Caribbean, however, has a response. Wärtsilä says its current gas engine technology produces about 90% less methane slip than engines from 20 to 30 years ago. The ship can also connect to a local power grid when the required port infrastructure is available, reducing engine use while it is docked. The company also has long-term goals. Royal Caribbean Group aims to launch a net-zero cruise ship by 2035 and achieve net-zero emissions across the entire company by 2050. It is working on biofuels, methanol, fuel cell technology, and more efficient ship designs. However, fuel cells are still experimental on large ships, and they are not currently Icon's primary source of power. So the truth is not completely black and white. Icon of the Seas uses more efficient technology than many conventional ships, but simply using LNG does not automatically make it environmentally friendly. The central question remains open. Should we only count the emissions produced when the fuel burns inside the ship's engines, or should we count the entire journey, from fuel production to the final molecule entering the atmosphere? That single difference determines whether LNG is truly a cleaner alternative, or whether it only looks cleaner. There is another world on board that passengers usually never see. A separate crew neighborhood has been created for the ship's roughly 2,350 crew members, spread mainly across 4 decks. It includes their own dining areas, bar, nightclub, gaming lounge, gym, and even a small barber shop. These spaces are reached through special corridors hidden from passengers. The crew cabins are much smaller than the guest rooms and are designed around necessity. However, Icon of the Seas includes improved facilities for its workers compared with earlier ships. Their dining area has porthole windows, while the main crew bar offers access to daylight and views of the ocean. Meanwhile, the upper decks feature the nearly 1,772 square foot, 3-story ultimate family townhouse, complete with a private balcony, movie room, indoor slide, and special guest services. So 2 completely different lives exist inside the same ship. On one side, maximum comfort for guests enjoying their vacation. On the other, a space-efficient life for the workers who keep that experience running. This contrast is not an accident. The ship's entire business model can be seen in the way its decks are designed. But one thing cannot be denied. People do not pay to board this ship simply to travel from one place to another. They pay to spend several days inside a floating world where the ocean itself becomes the source of water. Waste is turned back into energy, and 6 engines work like the heartbeat of an entire city. Fares on Icon of the Seas vary depending on the date, cabin, and itinerary. While standard rooms are relatively more affordable, reports say that the 3-story ultimate family townhouse has cost more than $100,000 for a 1-week sailing on certain voyages. Would you pay that much for an experience like this? Share your opinion in the comments, because here, people are not simply renting a cabin, they are living inside an engineering marvel that purifies salt water from the ocean, finds new uses for organic waste, generates its own electricity, and precisely turns its enormous body without a conventional rudder. It is one of the most extraordinary engineering achievements of the 21st century. At the same time, it leaves us with an uncomfortable question. How much money, fuel, and environmental cost are we willing to accept for 1 week of enjoyment? And Icon is not the final chapter of this story. In July 2026, its sister ship, Legend of the Seas, began sailing through the Mediterranean from Barcelona and Rome. The same shipyard, the same floating city concept, the same sense of wonder, and the same debate. When the sun sets over the ocean horizon, these ships look like cities of light from a distance. But that light represents more than luxury. Beneath it are the labor of thousands of people, extraordinary engineering, and our responsibility toward the future. If you enjoyed this video, subscribe to the channel, because the stories of the largest machines changing our world are far from over.